What if the closest sun-like star to Earth is hiding a planet right in the habitable zone? In August 2024, NASA's James Webb Space Telescope may have spotted it, a Saturn-sized world only 4.37 light-years away. It appeared as a faint, lonely dot, and then, months later, it vanished without a trace. Was this the closest alien world ever seen, or just a cosmic mirage? In the next few minutes, you'll hear the full story, the detection, the disappearance, and the high-stakes chase to catch it again. This could be history unfolding right next door. The discovery that shook the hunt for planets. For decades, astronomers have dreamed of finding planets around Alpha Centauri, the closest star system to our own. It's a binary system, Alpha Centauri A star very much like our Sun, and Alpha Centauri B, slightly smaller and cooler, orbiting each other every 79 years. If either of them hosted planets in the habitable zone, they'd be the closest potential worlds we could ever visit. But spotting such planets is incredibly hard. Even the biggest telescopes are overwhelmed by the blinding glare of the stars. Direct imaging of planets is usually only possible for giant worlds far from their stars, and never this close. That's why what happened in August 2024 was so remarkable. Astronomers pointed JWST's mid-infrared instrument, MIRI, toward Alpha Centauri A. To block out the star's brightness, they used a coronagraph, a special mask inside the telescope that acts like holding up your hand to block the sun's glare so you can see something nearby. What they found was unexpected. A faint but persistent point of light appeared just 1.5 arcseconds from the star, translating to about 1 to 2 astronomical units away. That's right in the habitable zone, the region where temperatures could allow liquid water to exist. They called it S1. It shone brightest at 15.5 microns, glowing at about 3.5 millijanskis, the kind of thermal signal you'd expect from a cold gas giant. Early estimates suggested it was about the size of Jupiter, but cooler, roughly 225 Kelvin, and with a mass between 90 and 150 Earth masses, making it more like Saturn in composition. The team didn't just take the image at face value. They ran multiple checks, modeling JWST's point spread function to see if it matched an actual object, comparing it with reference stars to rule out instrumental artifacts, checking archival data, including the VLT/NEAR project's Candidate 1, C1, spotted back in 2019. And here's where it gets interesting. S1's position lined up with C1's predicted orbit. Could it be the same planet, caught twice, years apart? If true, this would be huge. Not only would S1 be the closest directly imaged exoplanet to Earth, it would also be orbiting in the habitable zone of the nearest Sun-like star. The vanishing act after such an exciting detection, astronomers naturally wanted more data. In February 2025 and again in April 2025, JWST looked at Alpha Centauri using the exact same setup. But this time nothing. S1 was gone. At first, some thought this could be bad news. Maybe it was just an artifact after all. But the more scientists analyzed it, the more another explanation emerged. S1 might simply be hiding. If the planet's orbit is eccentric, meaning stretched out instead of perfectly circular, it could be swinging behind Alpha Centauri A from our viewpoint. In fact, simulations suggested an eccentricity of around 0.4 and a dramatic orbital tilt, anywhere between 50 degrees and 130 degrees relative to the Alpha Centauri binary plane. With such an orbit, more than half the time S1 would be lost in the star's blinding light. Statistically, there's a 52% chance we simply couldn't see it during those 2025 observations. The Alpha Centauri system itself adds another twist. Alpha Centauri B, the second star, exerts gravitational tugs that could warp S1's path, making it even harder to predict where it will be. And if S1 really is the same as 2019's Candidate 1, its predicted position in early 2025 would indeed put it behind the star, meaning the vanishing could be exactly what we'd expect. This wasn't a failure, it was a clue. The disappearance forced scientists to refine their orbital models, narrowing down where to look next. High stakes, and what comes next if S1 is confirmed, it would be one of the most important exoplanet finds in history. First, the obvious. It would be the closest directly imaged planet around a Sun-like star in the habitable zone. That's science headline material on its own. But the real excitement comes from its potential moons. Gas giants can't support life as we know it on their surfaces, but their moons might. In our own solar system, Europa and Enceladus have vast subsurface oceans under icy crusts, despite being far from the Sun. Around S1, with the right conditions, a moon could have liquid water and maybe even life. From a technology perspective, confirming S1 would prove that JWST's mid-infrared coronagraph can pull off one of the hardest feats in astronomy, directly imaging a planet so close to a bright star. That technique could be used to find dozens more in the coming decades. And this is just the beginning. The upcoming Nancy Grace Roman Space Telescope, launching later this decade, will carry an advanced coronagraph capable of studying such planets in even greater detail. If S1 reappears, Roman could probe its atmosphere, search for moons, and pin down its exact orbit. So when might we see it again? Current models suggest 2026 or 2027 will be the best chances. If it emerges from behind Alpha Centauri A as predicted, if that happens, the implications go far beyond adding a new planet to the exoplanet list. It would make Alpha Centauri A the nearest Sun-like star with a known planet in its habitable zone, instantly making it a prime target for future robotic probes or even far future interstellar missions. The chase continues right now. S1 is either a groundbreaking discovery or one of the most frustrating teases in modern astronomy. It could be our closest planetary neighbor, one we can see, hiding in plain sight. But whether it's real or not, the chase is already changing how we search for worlds beyond our own. It's teaching astronomers patience, precision, and persistence. In a couple of years, we'll know for sure. And if S1 turns out to be real, it won't just rewrite textbooks. It will change how we see our place in the universe. Until then, keep watching the skies, because sometimes the most incredible discoveries aren't light years away in distant galaxies. They're right next door. Thanks for watching. We'd love to hear your thoughts in the comments. If you enjoyed this video, don't forget to like, share, and subscribe. Your support means the world and keeps our journey going.